This example is asking you to find a linear expression that approximates this given equation, and they use the term around this x value here. So the words linear approximation, kind of bells and whistles should be going off if you see that language. You know, linear approximation, maybe they might say they want you to use a tangent line to approximate, so tangent line approximation. All of those bits of language mean the same thing, right? That's our math thesaurus right there. They're basically saying we need to create a tangent line that approximates this given equation at a specific x value. So we do this like other tangent line approximation games, except the nice part here is we just need the equation. We don't actually have to use it to find a value or to approximate a value. So step one of the process when we're doing this is we need to find what is the f of x that we're trying to approximate. Well, the beautiful part about this is they're giving us that equation. So 5x to the fourth plus 7x to the negative 3 minus 10x. Step two of the process, normally they would either give it to you or you would have to kind of come up with the x value that this thing is centered around. Your x naught value is very often the way they'll refer to it, or your a value. But our centered around value is x equals 1. Again, the nice part about this problem is they give us everything we need to do our work right at the beginning. Now the heavy lifting comes in on step 3 here. So really what we do to find this linear expression, this linear approximation, is we just need to find the equation of the tangent line. And that, again, is just another process that we have to run ourselves through. So let's go find the equation of the tangent line. That equation of the tangent line is going to be our final answer. So step one of the process for finding the equation of a tangent line is we need to find the point on the graph, the tangent point. Well, they give us this x value here, so they're giving us our x value, and we just need to use the equation that they've given us to find the y value that goes with it. So we want to know, what does f of 1 equal? So everywhere we see an x in that equation, we're just going to, in parentheses, plug in 1. Oops, not x. I just said plug all those x's in as 1. So make that a 1 to the negative 3 minus 10 times 1. You know, pop that into your calculator, do it in your head. We end up with 12 minus 10, so the square root of 2. So this is our y value right there. Step 2 of the process, that's where again, in this situation, the real heavy lifting comes in, and that's going to be to find our derivative. So we need to find f prime of x. So you'll take the equation that they gave you, f of x equals the square root of 5x to the fourth plus 7x to the negative 3, all of that minus 10x, and all of that the square root of all that. So to find the derivative of that equation, before we even get going with the derivative, we got to stop and say, I see a root. And anytime I see a square root or any type of root in a problem, I know that before I take my derivative, I need to do a rewrite of that root. I can't take the derivative of those roots. So this is our power over root rewrite. Anytime you have x raised to the power inside a root, you rewrite this as x to the power divided by the root. When you got a bunch of stuff inside your root, all of that stuff is inside a set of parentheses raised to the first, and then we have a square root, an unwritten 2 outside here. So doing our rewrite on this, we would end up with 5x to the fourth plus 7x to the negative 3 minus 10x, all of that to the power of 1 over the root of 2. Once we've done the rewrite, now we're ready to start doing our derivative. Now we're ready to start seeing what derivative do I need to work with here. And when I look at this right now, what I see is a bunch of stuff raised to a power. This is the classic of all classic chain rule setups. A bunch of stuff inside a set of parentheses raised to a power. My little saying that I use to remember the chain rule, my recipe that I use goes d in times d out. the derivative of whatever is inside those parentheses, so whatever is inside the parentheses, times the derivative of the outside here, which is usually just a big power rule. So following that to get my derivative, so f prime of x equals, I go ahead and I take the derivative of the inside piece first. So whatever is inside those parentheses. So that would be a power rule. Bringing my 4 down, 4 times 5 gets me 20x. Subtracting 1 from the power gets me x to the third. Bring the negative 3 down. Negative 3 times 7 gets me negative 21x. Subtract 1 from the power gets me negative 4. Then there's an unwritten 1 on that x back there, so I bring the 1 down. 1 times negative 10 gets me negative 10, and then we end up with x to the 0, and anything to the 0 power is 1, so 1 times negative 10. That's my dn, the derivative of the inside stuff. Then I'm going to multiply that by the derivative of the outside. The outside is really just this big power rule. You bring your 1/2 down in front, you leave alone all the stuff you already took the derivative of, and then subtract 1 from the power. 1/2 minus 1 gets us negative 1/2. So all that stuff that was inside there just stays inside there. We took the derivative of it already. So that's our derivative. And we need that derivative as we're coming through here now, because we need to find our actual slope, right? We're in the middle of finding the equation of the tangent line. And so step 3 now is find the slope, our m. And we find our m, our derivative. That's how we do it in calculus. So your slope equation in a calculus class is always your derivative equation. So what we're going to do now is we want to know what is f prime of our x value, which is 1. So we take and we plug 1 into this big nasty equation everywhere we see an x. So 20 times 1 to the third minus 21x to the, oops, not x. We're plugging in 1 everywhere we see an x. So 1 to the negative 4 minus 10 times 1/2 times 5 times 1 to the 4th plus 7 times 1 to the negative 3rd. Oh my goodness, 10 times 1 and all that to the negative 1/2 power. This thing cleans up. You know, you probably have to do it by hand because your calculator and roots don't really go very well together. They always give us out nasty decimals. So in this situation, when you simplify it all down, you'd end up with negative 11 over 2 times the square root of 2. This is our m. This is our slope. And so now, using our point from step 1 and our slope that we just got out on step 3, we finish up the process of finding the equation of the tangent line by plugging everything into our point slope form. So point slope, and this is one of the reasons I like memorizing it the way I do, is because it comes in useful when you're doing the actual work. So this is y equals m times x minus x1 plus y1. So our final step here, finding the equation of our tangent line, we get y equals m. M is our slope that we just found. That's negative 11 over 2 square root of 2 times x minus x1, which we got out from step 1. We have x1 and y1 up here. So x1 is 1 minus, plus y1. So plus y1, y1 is our square root of 2. And that is our approximation equation right there. So what we're saying is we have just created, they wanted us to find a linear approximation for this given equation. So the final conclusion, what you're getting out here is 5x to the 4th plus 7x to the negative 3 minus 10x is approximately this equation here, whenever you're really close to the x value of 1. You get away from that x value of 1 and all bets are off. You got to create a new equation of a tangent line. But for values close to 1, we can use that linear equation to approximate that big nasty equation they started us with. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.